Hi, I'm Robin Higgins, and this is Which Curve Represents the Behavior of an Enzyme? All right, so what enzymes are basically nature's catalysts. So if there's some kind of biological reaction that needs to happen faster, or in some cases slower, than it's going to happen naturally, nature will have an enzyme that helps it out. So there's lots of different graphs we could draw about enzymes, but let's take a look at what we're graphing temperature and reaction rate. So remember that an enzyme is a catalyst, so it's going to help the reaction rate. So in this first case, we've kind of got a stair graph with some plateaus and some increases. The second graph is just a straight incline, and then the third graph is kind of an upside down U shape. And so enzymes never behave like this. This is actually a type of graph that we see in phase changes. So if we were heating up solid water, an ice cube, and turning it into the gas phase, this is like what we would see. So this is not it. And this is just a straight incline. This is also not how enzymes behave. When there's a temperature, this graph implies that the reaction gets faster and faster the hotter you heat it, and there's a certain point when the enzyme would be destroyed by heat. So that's not true either. So this last curve is going to be how our enzyme is graphed versus temperature versus reaction rate. So we can see that, let's just say this is 80 degrees Celsius. So very hot, but some enzymes work at really hot temperatures. Let's say that now this is 0 and this is 200. So we can see that when it's freezing, this enzyme is not really working, right? It's too cold for it to do anything. And then as it starts to heat up, the reaction rate will go up, and the sweet spot for this enzyme, its ideal temperature is really 80 degrees Celsius. So that's perfect for this guy. And then any other temperature that's hotter than this, the enzyme will actually start to once again lose productivity, so the reaction will slow down. And then at a certain point, it'll just be too hot, the enzyme will be destroyed, and the reaction can't happen anymore. So pretty much when you're graphing temperature versus reaction rate for enzymes, this is the shape that we're going to follow. Because there's an ideal temperature, and then anything that's kind of flows away from that is going to make the reaction slow down. I'm Robin Higgins, and this has been What Graph Represents an Enzyme?